Hello students, I'm Anusha, your math educator. In the last class of polynomials, we learnt about zeros of a polynomial and their geometrical meaning. In this class, let's discuss about the relationship between zeros of a polynomial and the coefficients of the polynomial. Let's start with linear polynomials. What is the general form of a linear polynomial? It is ax plus b. And what about the zeros of a linear polynomial? It is minus b by a. What is b? It is the constant term in the linear polynomial, b. And what is a? It is the leading term or the coefficient of x. Therefore, the zero of a linear equation can be written as minus of the constant term by coefficient of x. It is minus constant term by coefficient of x. Let's verify this relation for a linear polynomial y is equal to 4x plus 5. Let's find the zero of this linear polynomial. How do you find the zero of a linear polynomial or any polynomial? You equate the polynomial to 0 and then you solve for x or the variable. So 4x is equal to minus 5 and x will be equal to minus 5 by 4. Minus 5 by 4. Now let's verify the relation. So what is the relation? It is minus constant term over coefficient of x. So minus, what is the constant term? It is 5. Minus of 5 by, what is the coefficient of x? It is 4. So this ratio is minus 5 by 4. But what is minus 5 by 4? It is nothing but the zero of the linear equation. Therefore, we can say that the zero of a linear equation is nothing but the ratio of minus of the constant term and coefficient of x. Okay. Now, let's discuss this for quadratic polynomials. What is the general form of a quadratic polynomial? It is ax square plus bx plus c. And let us assume that alpha and beta to be the zero of this quadratic polynomial. Then we can say that x minus alpha and x minus beta are the two factors for the given quadratic polynomial. You have learned this in class 9. By the factor theorem, we can say that if a is a zero of the polynomial, then x minus a will be the factor of that polynomial. Hence, we can say that x minus alpha and x minus beta are the two factors for the given quadratic polynomial ax square plus bx plus c. So, this quadratic polynomial can be written as k into x minus alpha into x minus beta, where k is a non-zero constant. Okay. Now, simplify the expression on the right hand side. So, this can be written as k into x will be x square, x into minus beta is minus beta x, minus alpha into x is minus alpha x, and minus alpha into minus beta is plus beta. Now, group the like terms. So, this is k into x square minus alpha plus beta into x plus alpha beta. Now, multiply this k to each term of the expression. Therefore, we get ax square plus bx plus c is equal to k into x square minus k into alpha plus beta into x plus k alpha beta. Now, on comparing the coefficients of x square, x and the constant, we can write as a is equal to k. What is the coefficient of x square on LHS and RHS? It is a and k. Therefore, a is equal to k. Now, what is the coefficient of x on LHS? It is b. And what about on RHS? It is minus k into alpha plus beta. Therefore, b is equal to minus k into alpha plus beta. What is the constant term on LHS? It is c. And what about RHS? It is k alpha beta. Therefore, c is equal to k alpha beta. Now consider the ratio of minus b and a, minus b by a. So minus of what is b? Minus k into alpha plus beta, and what is a? It is k. Now minus into minus is plus, and on cancelling k we get minus b by a as alpha plus beta, alpha plus beta. Consider the ratio of c and a, c and a. What is c? It is k alpha beta, and what is a? It is k. On cancelling k we get c by a as alpha into beta, alpha into beta. So for the polynomial p of x is equal to ax square plus bx plus c, we get two relations. One of them was minus b by a is equal to alpha plus beta. What is this? This is nothing but minus of coefficient of x by coefficient of x square, isn't it? B is coefficient of x and coefficient of x square is a. It is a. And on the RHS we got alpha plus beta, alpha plus beta. Alpha and beta are the two zeros for the polynomial ax square plus bx plus c. Alpha plus beta means the sum of the zeros. Therefore, for a quadratic polynomial, sum of the zeros is equal to minus of coefficient of x over coefficient of x square, coefficient of x square. The other relation that we got was c by a is equal to alpha into beta, alpha into beta. What is c? It is the constant term. And what is a? It is coefficient of x square. So this is equal to product of the zeros. Alpha and beta are zeros for the polynomial. Therefore, alpha into beta is the product of the zeros. Therefore, for a quadratic polynomial, product of the zeros is equal to constant term over coefficient of x square. These are the two important relations for quadratic polynomials, which relates between the zeros of the quadratic polynomial and coefficients of quadratic polynomials. Let's solve some of the examples on this. So here is the first problem. Find the zeros of the given quadratic equation and verify the relationship between the zeros and the coefficients of the quadratic polynomial x square plus 5x plus 6. So a quadratic polynomial has been given x square plus 5x plus 6. We have to find the zeros for this quadratic polynomial, and then we have to verify the two relations which relates between the zeros and the coefficients of the quadratic polynomial. First, let's find the zeros for this. So how do we find zeros of a quadratic polynomial? We equate the polynomial to 0. We equate the polynomial to 0. Then we factorize it, isn't it? Let's factorize by splitting the middle term. So I split the middle term 5x as 2x plus 3x. See, 5x has been written as 2x plus 3x. Now take out x as the common factor from the first two terms. You get x plus 2. And from the next two terms, take out 3 as a common factor. 3 into x plus 2. Now take out x plus 2 common. X plus 2. On taking x plus 2 as the common factor, we get x plus 3. This is equal to 0. See, the product of two numbers is 0. The product of two numbers is 0. Then either of the one must be equal to 0. Therefore, we can write that x plus 2 is equal to 0, or x plus 3 is equal to 0. Either x plus 2 must be equal to 0 or x plus 3 must be equal to 0. Now solve this for x. So x is equal to minus 2 or x is equal to minus 3. So the two zeros for the given polynomial, given quadratic polynomial is minus 2 and minus 3. So the first part is completed. Now let's look on to the second part, that is to verify the relationship between zeros and the coefficients of the quadratic polynomial. So the given quadratic polynomial is x square plus 5x plus 6. The two zeros are -2 and -3. So now let's verify the first relation. It says that sum of the zeros must be equal to minus coefficient of x over coefficient of x square. Consider the sum of zeros. Sum of zeros. So the zeros are -2 and -3. What is their sum? It is -5. See, this -5 can be written as -5 by 1, right? -5 by 1. And what is 5? It is nothing but the coefficient of x. 5 is coefficient of x. And what is 1? It is the coefficient of x square. Coefficient of x square. Hence we verify sum of the zeros is nothing but minus of coefficient of x by coefficient of x square. Okay. Now let's verify the second relation, which states that product of the zeros must be equal to the ratio of constant term and coefficient of x square. What is the product of zeros? Product of 0 is -2 into -3. -2 into -3 is 6 plus 6. Now 6 can be written as 6 by 1, isn't it? 6 by 1. What is 6? It is the constant term in the given quadratic polynomial. 6 is the constant term over, again, what is 1? It is the coefficient of x square. Coefficient of x square. Hence we verified that product of the zeros is nothing but constant term over coefficient of x square. Therefore, the given polynomial x square plus 5x plus 6 verifies the relationship between zeros and the coefficient of the polynomial. Okay, let's do one more question. The question is, verify the relationship between the zeros and coefficient of the quadratic polynomial 2t square minus 10. So here we are asked to verify the relationship. So first we have to find the zeros for this polynomial, and then we should verify the relationship between zeros and the coefficient. Okay. Let's equate the given polynomial to 0 in order to find zeros of the polynomial. So take out 2 common from this. T square minus 5 is equal to 0. See, the product of two numbers is equal to 0. 2 into t square minus 5 is equal to 0. Then either of the one must be equal to 0. But 2 cannot be equal to 0. Isn't it? Is 2 equal to 0? Never. Therefore, t square minus 5 must be equal to 0. Now, t square is equal to 5, and on taking square root on both sides, we get t is equal to plus or minus root 5. Plus or minus root 5. Therefore, the two zeros for the given polynomial are root 5 and minus root 5. Minus root 5. The two zeros are root 5 and minus root 5. Now let's verify the relationship between zeros and the coefficients. So the given polynomial is 2t square minus 10. What is the coefficient of x square? Or since the given polynomial is in the variable t, what is the coefficient of t square? It is 2. It is 2. What is the coefficient of t here? See, there is no term t in the given polynomial. Therefore, its coefficient must be equal to 0. Coefficient of t is 0. It must be equal to 0. And what is the constant term? It is minus 10. Constant term is minus 10. Now let's start to verify the two relation. So one of the relation is sum of the zeros must be equal to minus coefficient of the x by coefficient of x square. Consider the sum of the zeros. What are the zeros that we got? It is root 5 and minus root 5. So what is the sum of root 5 and minus root 5? It is 0, isn't it? The sum of the zeros is 0. Now what is minus coefficient of x by coefficient of x square or the variable t? So what is coefficient of t? It is 0. And what is coefficient of x square or t square? It is 2. 0 by 2 is 0. That means the sum of the zeros is nothing but the ratio of minus coefficient of the x and coefficient of x square. Therefore, the first relation is verified. Now let's look on to the second relation. It states product of the zeros is equal to the ratio of constant term over coefficient of x square. What is the product of the zeros? It is root 5 into minus root 5. So plus into minus is minus, root 5 into root 5 is 5. It is 5. See, this minus 5 can be written as minus 10 by 2. Isn't it? Minus 10 by 2. What is minus 10? It is the constant term. Constant term over what is 2? It is the coefficient of x square. Coefficient of x square. Therefore, the second relation 2 is verified. Now, let's look on to one more problem. Verify the relationship between the zeros and the coefficients of the quadratic polynomial abx square plus b square minus a square into x minus ab. This is the given polynomial. Here we have to find the zeros of the polynomial and then verify the relationship. Okay. Now let's find the zeros for the given polynomial by equating the polynomial to 0. This is equal to 0. Expand this middle term. abx plus b square into x minus a square into x minus ab is equal to 0. Now, from the first two terms, take out bx as the common factor. Bx. So, what is left? ax plus b. ax plus b. From the next two terms, take out minus a as the common factor. Minus a. So, we are left with ax plus b. ax plus b. Now, take out ax plus b as the common factor. So, we are left with bx minus a. See, the product of two terms is equal to 0. Therefore, either of the one must be equal to 0. This implies ax plus b is equal to 0 or bx minus a is equal to 0. ax plus b must be equal to 0 or bx minus a is equal to 0. Let's solve this for x. So, x is equal to minus b by a or x is equal to a by b. The two zeros for the given polynomial is minus b by a and a by b. Now, let's start to verify the relationship between zeros and the coefficients. Okay, the given polynomial is abx square plus b square minus a square into x minus ab. So, what are the two zeros? it is minus b by a and a by b. These are the two zeros for the given polynomial. Let's find the sum of the zeros. It is minus b by a plus a by b. Take LCM. The LCM is ab. On simplification, we get the numerator as minus b square. On cross multiplying b, we get minus b square plus a square plus a square. See, this is the sum of the zeros. Now consider minus coefficient of x by coefficient of x square. Minus of coefficient of x by coefficient of x square. Minus, what is the coefficient of x? It is b square minus a square. By what is coefficient of x square? It is ab. Simplify this. This is nothing but minus b square, minus into minus is plus a square by ab. Therefore, the sum of the zeros is same as negation of the coefficient of x by coefficient of x square. Hence, we verified the first relation. Now let's verify the second equation. So it says product of the zeros must be equal to constant term over coefficient of x square. So consider the product of zeros. It is minus b by a into a by b. A by b. Cancel out a and then b. So we get minus 1 as the product of zeros. Now, what is the constant term? It is minus ab. Minus ab. And what is the coefficient of x square? It is also ab. This is also ab. On cancelling ab, we get minus 1. Minus 1. Therefore, product of the zeros is same as constant term upon coefficient of x square. Hence, this polynomial also verifies the relation between zeros of the quadratic polynomial and its coefficient. Okay, that's it for the class today. In this class, we learnt sum of the zeros of a quadratic equation is equal to minus of the coefficient of x over coefficient of x square, and product of the zeros is equal to constant term over coefficient of x square. Okay, in the next class we shall continue more problems on this. Until then, see you. Bye bye.